Welcome everyone to the last talk of the conference, and it's going to be Asynchronous PHP today. My name is Florian. I see some familiar faces from tomorrow, so you know me. And for the other ones, I'm a PHP developer since 22 years, since September 2000. And I'm working remote at a company called Networld, and I'm contributing to open source a lot, namely GraphQLite, PHP Unit, and the PHP core itself. Let's dive into the problem that I brought with. So a few years back at an e-commerce company, we had a problem that our companies were waiting too long at the checkout. By the word checkout, I mean that point in the checkout funnel where you're at the last page, you have chosen your payment options, you have added your invoice address, delivery address, all these things. You just have the summary, you have this buy now button, you hit that buy now button, and you wait for the thank you page to show up. So we got some complaints that the customers are waiting too long, so we added some time tracking. And we found out that some customers waited for like 5 seconds for this page to show up. We had customers waiting for 10 seconds. And we even had, like very rarely, but we had customers waiting for roughly 20 seconds for the thank you page to show up. This is totally horrible. I could not imagine myself sitting in front of my device and waiting for 20 seconds for a page to show up. And we found a correlation, like what makes people wait long. And the correlation is that the more article people have in their shopping cart, the longer they wait, which is a problem. I mean, the more stuff they buy, the more money they bring us, so they shouldn't wait so long. And this is only the server-side answer. There's also additional tracking stuff on the client happening, a lot of JavaScript. So what were we doing? We were checking out what's happening during the checkout. So besides the obvious, that we somehow store the order in the persistence layer and deduct the stocks, what we do is we send a lot of tracking data to services, usually marketing services. So every now and then, some of the marketing came, and we have this awesome new tool. You just need to copy-paste the snippet and send data to them. And someone did. But we're not only sending data to tracking services for marketing, but also for us, because if you have this sorting by best in e-commerce stores, it's not sorted by someone's not sitting there and sorting these things for you. It's all based on tracking data. So we're sending a lot of tracking data to a catalog service to then ask them for the how we should order the articles for that specific customer. The next thing we do is we send an order confirmation email to the customer. So usually you buy stuff, you get an order confirmation email that your order has been placed and money has been deducted and all these things. One thing that we found here, this is more on a side note. First of all, we were sending out those auto confirmation emails via SMTP. And SMTP server can be slow, especially in this case, because we found out that every time we make a connection to the SMTP server to send out an email, after the initial hello command in the SMTP protocol, the server waited for 1 or 2 seconds just to slow down spam. This is a problem for us in this case, because while the script is waiting for the SMTP server, the customer is waiting in front of its device. And another thing that we found out is that we're not only sending out one order confirmation email, but also a second one to the shop owner, which is particularly interesting because we are the shop owner, and nobody know that we should receive such an email. So you have like 2 to 4 seconds waiting for 2 emails, which is not nice to the customer. The next thing we do is we capture money from a payment gateway. This usually involves some API calls. So for example, if a customer goes through the checkout funnel, they decide to pay with PayPal or some credit card or whatever, what you get is get a token, and at this point in time when they hit buy now, you send an API request to actually capture the money. And one more thing we do is sometimes people hit this checkbox that they want to have a newsletter. And so we register them to the newsletter. This is just here because of one thing. The tool that we were using back then was particularly bad in API design. because they had like 300 to 500 milliseconds for a response. And if a customer was not known to them, we needed 3 API calls. So that's roughly a second that you get as a penalty if you want to have the newsletter. All these things that we have here, like besides the obvious, have something in common. What they have in common is that the customers in the checkout process are waiting for stuff that they don't know about, like all the tracking data. Probably it's good that they don't know about, and they don't care about. The thing is, if they don't know about these things, and if they don't care about these things, then I would say it's best that they shouldn't wait. So what we can do is, we can just postpone stuff to later and not do it now. And I want to tell you some stories from regarding the emails. We had this case where we weren't sending out order confirmation emails to customers, like for a day. And we only noticed because one of the colleagues was buying stuff in our shop system and was complaining to us that there is no order confirmation email, if everything is all right. And we checked the logs and we found out that everything's not all right. But interestingly, we have had a customer service department. Nobody was calling, so no customer cared about this order confirmation email not being there. Interestingly, a customer call you when they do not get a parcel dispatch notification. Then they call you. But for the order confirmation email, no one really cares, at least in our case. The other thing is about capturing money. Most people would say that you should capture the money as soon as the person hits the buy now button. Then you capture the money and then everything can go forward. The interesting thing here is usually what you get from PayPal, credit cards, whatever, you get a token and you can use this you have an authorization already, so you have the guarantee that you can capture the money in a given time frame. And the time frame usually is not just minutes or seconds or hours, it's usually weeks. So you usually have like a week or 2 weeks to use that token to capture the money. You should probably make sure that you capture the money before you send out the parcel. But besides from that, you don't need to capture the money at exactly this point in time. Okay, so it sounds a bit easy to just do stuff later, but how did we do it? What we did is we added RabbitMQ to our stack. So we decided to go to an asynchronous architecture. The overall idea is we don't do these things at this point in time. We create a JSON, somehow an event, send it into RabbitMQ in this case, and then have some tools that magically do these things asynchronously, so the customer doesn't have to wait for all these things to happen. Yeah. Disclaimer, if you have something that works for you, just stick with it. Adding new technology to your stack usually brings a lot of new problems. We had to learn the hard way. We had 2 RabbitMQ servers replicating each other. And for some reasons, I don't know, they got an update at the same time and rebooted at the same time. And then the one was waiting for the other. And we had no RabbitMQ anymore. OK. Really very simplified how RabbitMQ works for you if you don't know how this works. You have a producer. The producer in our case is the e-commerce system, the whatever you have. In our case, it's the e-commerce system, the shop system, that produces a message. Somehow, it could be a binary format, but it's usually simpler if you just have a string representation. And you send it over the wire to a RabbitMQ. And the RabbitMQ consists more like simplified of these 2 parts. You have an exchange. You give the message to an exchange. The exchange is here to route the messages to queues. Then in this example, we have 2 queues. So the exchange gets 1 message and duplicates it into 2 queues. And then on the other side, we have, in this case, 1 consumer per queue. And those consumers are then, for example, PHP scripts, how we're going to see later, that actually do something with the message that they got. OK, let's concentrate on the consumer part, because that's the neat part. We wanted to build an asynchronous consumer. So what we wanted it to do is it needs to consume messages from RabbitMQ, obviously, because we decided so. We decided that one of the first services, or one of the first things that we that we extract from the monolith, from the shopping system, is to send the tracking data to a service, one of those services which had a particular bad API and was responsible for people waiting longer because their API is not, we send them the order with all the articles and numbers and stocks, but for every article, we have to make one API call. So if you have 10 different articles, we have 10 API calls. We wanted it to be non-blocking and asynchronous. Why we want to do asynchronous? So before we decided to make this change in the architecture, we had like I think it was 8 or 9 application servers running up front, and those were just doing all these stuff, and basically they were waiting. And the idea here was that we have 2 RabbitMQ servers and have 1 consumer per queue. And this 1 consumer should be able to catch up with all the messages as comes in. And when we just like consume a message from RabbitMQ, and that's a JSON, and we just make an HTTP call out of it, I would say 99% of the time, the process is waiting for stuff. So we wanted to fill those gaps with handling other messages, and so we thought async would be a good idea. And we want it to be written in PHP. You might ask, why PHP? If you fire up your favorite search engine and ask for asynchronous software development, PHP might not even show up. What you can do, you can go over to Stack Overflow and ask the nice fellows over there that you want to do asynchronous software development in PHP. But probably they ask you why you just don't use Node.js. OK. You can actually ask this question, and you can actually, there are answers to this question. First of all, PHP has the native functionality to write asynchronous code since PHP 4.3. But to be fair, not a nice interface to do so. But there are cool libraries doing the heavy lifting for us. So you have no promises, you have no async await keywords, you don't have all of these things natively in PHP. But there are libraries out there that do this stuff for us and abstract these problems away. And these libraries work on core PHP without any extension. So just every PHP version that you have, like not every PHP version, but I think I'm going to talk about ReactPHP, and it supports PHP back to 5.3, I think. I hope nobody is using that anymore. But if you do, you can still use asynchronous PHP there. And one of the things why we choose to do it with PHP is we already understand it anyway. We understand the ecosystem. We know how to write tests. We know how PHP Stan and Psalm work, and we know how Composer works, how we get our packages in, all these stuff, and all these things, all this every setup. And we decided that it's probably a good idea to start a new, let's say, programming paradigm in an environment that we're already familiar with. That doesn't mean that you should not check out new languages every now and then. OK. Yeah, exactly. The library I want to talk about is ReactPHP. That's one of those libraries that does the heavy lifting for you. So you don't have to interact with the stream select API and all these things. ReactPHP supports PHP 5.3 and upwards. And I want to give you a quick introduction of how this magic thing works. So the heart of ReactPHP is the reactor pattern. Implements the reactor pattern is the event loop. And what you usually see in all React application is that you somewhere in the code, usually at the start or at the beginning, you fetch your event loop. Then ReactPHP checks if you have any extensions installed that will help it, like the XUV or XEvent. If you don't have those installed, it fallbacks to stream select API. And then you register your event handler and all these things. You do something, and then you see a loop run. That's usually what's there. And if you only have the event loop, we cannot do very much with it, but you can execute. This is pretty nice. You can just, on the loop itself, call add periodic timer, give it a number of seconds. So you say, every second I want this function to be run, and it runs this function every second. There is a difference between actually doing it like this, or what you could also say, you could just have a for loop and sleep for a second. But the thing is, here, this file will be, this function will be called every 1 second, based on the timer, on the clock of your computer. And so it's not including the CPU time that you need to do whatever done here and here. So that's how you add a periodic timer, just that you know it. If you handle with stream data, so if you want to read files from a disk, or if you write files to disk, there is the React Stream library, which gives you a readable resource stream or writable resource stream. You give it a file handle. The library handles then everything for you. That makes it asynchronous, so it sets the file handle non-blocking. And what you do is you register your event handler. So you say, whenever there's data available for me to read from this stream, call this function with the data. And whenever we are finished, when we are at the end of the file, call this function. And then we can run it. Let alone, those examples doesn't make sense. You can just like fopen and echo out all the things, or can forget contents, and that's it. If you do multiple of these things, then you start to filling the gaps between the times where you're waiting for the hard drive, for memory, for external I/O. And then there's one thing that's a bit more complicated, but you should know about. There's the deferreds and promises. With deferreds, you probably won't have much to do. Deferreds are interesting when you are building a library that does some computation. Just that you know, a deferred represents a computation, like a unit of work, something that has to be done, or something that has already been done, but it's not completed, or may not have been completed. And a promise represents the result of that computation. So in most of the time, or a lot of stuff that you see when working with ReactPHP is that you get a promise, and you have a done function that you call, and you give it a function that should be called whenever the result is there. So usually a lot of functions that you call in ReactPHP don't give you strings or integers or objects or something back. They give you a promise back. They give you back the promise that someone in the future probably they will give you a result, and then you can call it and give it a result handler. What should be done whenever we have the result. And deep in the library somewhere, someone will call the result function the deferred, and that result function, the deferred, will then call the done function on your promise. If you want to go deeper on the topic, there is a talk from Carl Evans. It's called Promises, and you can find a recording on YouTube. Okay, this is just a basic overview of how it does. Let's go back to our asynchronous consumer that we actually want to build. We have some stuff that it should do. First of all, we need a way with ReactPHP to consume messages from RabbitMQ. On the one side, on the other side, we need to send HTTP calls to a tracking service, and we need to think of how should the payload look that we're going to send through all this stuff. So, consuming messages from RabbitMQ, you can use Bunny. BunnyPHP is a library that is a pure PHP implementation, and it has a synchronous and asynchronous interface to RabbitMQ, which is nice, particularly nice in this case, because we could use the same library in the producer, so in our e-commerce system, and the same library in the asynchronous consumer. So the idea was that you have a pretty different interface, but in the end, what we hoped for was that we have the same bugs or no bugs. Okay, so what do you do in order to connect to a RabbitMQ server and consume messages? It all fits on this slide. We need our loop. Then we need the RabbitMQ client. You usually give it just a loop and then register its handler. And what you can see is we have the client. The client has a connect method. The connect method gives back a promise that it will somehow connect to the RabbitMQ server. This actually works. If you have RabbitMQ running on localhost on the default port, then it will actually work like this. It gives you a promise. The then functions, whenever the promise is resolved, call this function. And we get the client in the function call. And you need to establish a channel. So what you do is you just call the client the channel method. The channel method also gives back a promise that it will somehow do this. So we have the then call, do the next promise for the channel. We give the channel. And on the channel, finally, we can call a consume function. And the consume function has two arguments. The one is a callback to a function that's been called for every message that we receive, and then the name of the queue that we want to listen on. And then in the end, we call loop run, and this magically connects to RabbitMQ. And whenever there is a new message in the hello queue, RabbitMQ will push that message toward the consumer, and this function is being called for every message. And then there's one thing you need to know when communicating with RabbitMQ is you need to acknowledge a message. So after you have worked on the message and everything is done, you acknowledge to RabbitMQ that you're finished, and RabbitMQ can remove the message. So that's the one side. The other side is that we need to send HTTP request out there. And there is also a library, ReactPHP. It's a PSR7 HTTP client. And it can send out post, HTTP, GET requests, whatever you want. Basically the same thing. We have an event loop. We need the browser, give it the loop, and then you can, on the browser, call get the URL wherever you want to call, and it gives you back a promise that it will give you the result from the server whenever it arrives. And then you have a handler function. It gets the response. And in this case, you can do anything with a response. In this case, we're just dumping out the headers and the body just to show that it actually works. And then you can loop run, and magically it should work. So the last thing we need to check out is the payload that we're sending through all of this. This is a very stripped down version of what we are sending through, because there's way more information about the order. But we decided to go with a simple JSON based on schema.org order. So you can just go to schema.org/order and you see the definition of how this should look like. And you can pretty easily find validators for these JSON formats. And what we have is, in the order, we have our customer. Customer is of type person. It has a name and an email address. We have ordered items, an array of order items then. They have a order item number, they have a quantity, and they have a name, and we have offers of type offer, which has a price. So we know all of these things in this JSON. And we don't need to come up with a new standard or think our own stuff. You can just rely on schema.org order. So we decided to go with that JSON. And what I have for you is a fully working example in 2 slides. But there is should be probably the disclaimer should be bigger. This is no advice, don't do this. But it's working, okay? Basically, it's just smashing together the slides that we had earlier. We need our event loop. We need the Bunny client. We need the HTTP browser. And then we connect to RabbitMQ, establish a channel, and register our consumer. And the consumer is just an app that we have on the next slide. And this is the consumer function. So what we do is, in message content, we find the body of the message, basically the JSON, as a string. We call JSON decode on that, then we have it. And for the API that I mentioned, where we had to we could not just report the order, but we have to report every single article that has been bought. What we do is we iterate over the order items and call a browser post for every single order item that we have and give it the SKU and the amount. And all we get in return from browser post is a promise that it will actually send out the HTTP post request. And so we just collect all the promises. And in the end, we wait for all the promises to be done. So what we do is there is a React promise all function that you can give an array with promises, and it gives you back another promise that will fulfill when all the promises have been fulfilled. And in the end, we just acknowledge to RabbitMQ that we are ready and everything has been done. That's basically it. But as you see, there's no logging, no exception handling, no error handling, no nothing. It works on the happy path. Hopefully nothing goes wrong. Some golden rules when you do asynchronous software development. Asynchronous code does not guarantee execution order. Let's go back to this slide. The thing here is, when we get back the promises from the browser post message, it might be that depending on how many order items there is and how many post requests we do, it might be that sooner or later in this loop, the first promises will be resolved, but we don't know. So one of the things is when you're working with promises in an asynchronous software development, you should not rely on global state, because if you do, things will get tricky. Asynchronous does not mean faster. Things take their time. So if you send out an HTTP request to an external server and the external server takes 300 milliseconds to respond to you, It still takes 300 milliseconds to respond. The only thing that asynchronous means in this case is that in these 300 milliseconds, you can start doing other stuff. You don't have to like actively wait for the result, for the response to come in, but you can start handling additional messages. And asynchronous PHP, as we have it here, is the same as in Node. It's not a multi-process. There's no other process running. There's no forking. There's no multi-threading. It's a single thread. That also means every time you do something that blocks your thread, your entire application will block. So if you have a file get contents somewhere because you're lazy, and it takes a second for the computer to actually give you the contents of the file, or 10 seconds because it's a network-mounted file, something, your entire thread will block for this time. And even echo and other things can block your process. If you are deeper interested in this topic, ReactPHP.org is the go-to place. They have an amazing documentation. Then Sergey made a ReactPHP series of YouTube videos. If you're good at learning from YouTube videos, you can watch the series. Then there is a talk from Christian Lück, one of the maintainers of ReactPHP, called Pushing the Limits of PHP. You can find that recording also on YouTube. And if you're interested in the slides or talking to me, .box.org is my domain. Thank you very much.
Is there any questions?
How is it with max execution time?
Sorry, with what?
Max execution time of the PHP.
Ah, you turned that off. The idea is to use this for long-running process. So in our case, we have a worker for the RabbitMQ, and you just start that one. And back then, we started this with supervisor D, so it kept it alive whenever it died.
I have a question from the chat. Are PHP fibers with scheduler a possible alternative for your scenario?
Interestingly, you could use the same thing, and ReactPHP has a backend for PHP fibers. So ReactPHP could use PHP fibers to do the same thing for you.
And the next question is, does the consumer always need to run as a Linux service, system, or a supervisor?
Depending on what you want. Like back then, we had supervisor D to actually keep the process alive and inform us when it died. Today, you could also build it in a Docker image and have Kubernetes take care of this.
Thank you. Any more questions?
Thanks for the talk. In terms of the asynchronous, let's say for the HTTP requests that's on your slides, if you're dealing with, let's say, third-party libraries through Composer, but they're not written to do it in this way, obviously they're kind of written in a more classical way, maybe they use Guzzle. Is there any way to wrap those libraries in the same asynchronous paradigm so you can do, let's say, multiple HTTP requests to different third parties using their own SDKs? Or would you need to like rewrite those SDKs?
Yeah. The problem if you wouldn't like wrap this somehow, they would block your thread, and you're not asynchronous anymore. There is a wrapper from Christian Lück. You should check out the github.com/clue namespace, where he has his stuff, and he has a wrapper that then for you actually forks a process away, so that they can run the whatever blocking stuff you have. And then basically for you, the interface is you have a promise and you call it, and that's everything. And the library takes care of you in the backend by technically creating a fork and letting the blocking stuff run for you, and then coming back with the response.
I guess that's only CLI, right?
No, it's not only CLI. You can run a web server with these things.
Yeah, but how would you? But FPM wouldn't let you fork a process, would it?
No, you wouldn't have FPM in between, but you could bind to port 80 and just handle a HTTP request for yourself.
Yeah, and I guess follow-up question, same topic. Would you say that if you are writing an SDK for your service application now, should you take that into account? Should you allow your clients to use your service in an asynchronous way?
I would say totally yes, but I think
You don't really see that a lot, but should it be happening more, I guess?
I think it should be happening more. I think you see the HTTP library is PSR7 compliant. So to a certain degree, you don't need to do too much. Probably what's bad in this is that the API and your SDK should be pretty easy to use. And if you give them PSR7 messages that they could somehow send however they like, then it gets more complicated for you. In the end, it depends on the demand, I would say. If you have customer demanding this, should not be too complicated.
Thank you for presentation, and I have one question. What about final result? Did you done some benchmark after implementation of this?
The first thing was about the first thing we did was about the emails. Like we had these 2 emails where we were sending out, and one email that we received ourselves. We found out that one person in the financial department was receiving those emails, and they had a rule to automatically delete them. So we just did not send out that email anymore. That was an easy second to spare. The other email was also roughly a second. And in the end, we didn't have this. Correlation anymore. That the more articles you buy, the longer you wait. That was gone the moment that we replaced that service. And for the other things, it's usually you can say you have one fixed amount of time that you need in order to create this JSON and send it to RabbitMQ. But that's fixed for every customer now, and it's not depending on the number of articles they buy anymore.
Thank you.
Any more questions?
Hi. So I had a similar problem where the checkout was slow and we moved everything after the checkout. But once you move all these send emails and call APIs outside of the checkout, does it make sense to use this asynchronous stuff, or it has all the time in the world to still run sequentially?
It still has all the time in the world. So let me just go here. Yeah. So one of the problems that we in theory, we thought it might be a problem. Is that you have 8 application servers, a lot of customers, they send messages to queues, and things will start to pile up. And you have in the night time at 2 o'clock, at least in the shop system back then, nobody placed orders. So they have time enough to catch up and then start the next day. The other thing you could do is you could just spawn more workers. RabbitMQ will not send every consumer the same message. It will just round robin distribute the messages. So if you spawn more workers, then you don't need this asynchronous stuff. Basically, the truth why we did it this way is when all you have is a hammer, all the problems look like nails. And in 2017, me and my team attended the PHP conference here. And in the rooms over there, Christian Luc was giving his talk about pushing the limits. And we saw this new and shiny hammer. And we immediately knew that this could be an amazing thing for us to build. And so we did.
Okay, thank you.
Anybody else? No? Okay. Yeah, then thank you very much for your talk. A little applause for you.